Hello and welcome. This is going to be our homework help video for the parallel and perpendicular lines investigation. Let's go through page number 2 here. Our directions are to graph the points and then use a ruler to draw a line that passes through them. Use the designated colors to draw each line. So step 1, the first point is -3, 2. To plot every point, I start at the origin. The first number tells me to count left to right, the correct number of units, and the second number tells me up or down. So -3 means go 3 to the left, and then the +2 tells me to go 2 up. I make a point. The next point is at 0, 4. So I'm going to go to my 0, I'm going to go up 4, 1, 2, 3, 4. 2 points is all you need to make a line, because there's only one line that will go through those 2 points. I'm going to connect these up with a straight line. It's kind of like that. And now this investigation is all about parallel lines. So I'm going to try to figure out which of these black lines is parallel to the line that I just created in red. Our definition for a parallel line is 2 lines that stay the same distance apart from each other forever. So if I look at this line, and then this line that's labeled B, you can tell that this distance right here is the same as this distance right here. They look like the same, it's the same line, just shifted over, but not turned at all. I can make a mark that looks like this to show that these 2 lines are parallel, kind of an arrow that goes along the line. And now while I'm at it, I'm going to find the equation of this red line. To find an equation, I need a slope and a y-intercept. So I can fill in the equation y equals mx plus b. To find the slope, I'm going to use those 2 points and connect them with a right triangle. It's called a slope triangle. It's got a little right angle right here. And this will tell me the rise and the run. How far up I go is the rise, how far over I go is the run. This triangle rises 1, 2, and then runs 1, 2, 3. So the rise over run equals 2 over 3. Now B is a little bit different. B is our y-intercept. We have to look, this is our y-axis right here. We have to look where our line crosses the y-axis. It crosses right here, so I go back to my origin and I count up until I get to this point. 1, 2, 3, 4. So now I've got a B value of 4. Let's fill that in right here for the red line. Y equals 2/3 x plus 4. All right. Time to do the brown line. So the first point is at -5, -1. I go back to my origin. The first number is negative, so I count to the left. 1, 2, 3, 4, 5. The second number is a -1. Because it's negative, I count down 1. And I make a point. The next point is 5, -5. Back to my origin, over 5. 1, 2, 3, 4, 5. I then go down 5. 1, 2, 3, 4, 5. Draw a point, connect them up with a straight line. And we're going to do our best to make it go right through those points, just like that. Now let's see, is this parallel to any of these black lines? It sure is. It's parallel to this line over here that's marked line A. To show that these are parallel but not parallel to these, we're going to use a similar symbol. We're going to make 2 arrows this time to show that these are parallel to each other but not to these ones over here. Let's now find the equation of this brown line. I can use any 2 points that it goes through. I'm going to use this point right here. It looks like it goes exactly through that grid line. And then over here, which is one of the points it was supposed to go through. To connect, I connect these with the right triangle. Let me do a little better. And then I find its rise, but I always go left to right. So when I find the rise, I notice that I go down 2. So that makes the rise -2. And then go to the right 1, 2, 3, 4, 5. But because I'm going to the right, that's positive. So my rise over run becomes -2 over 5. Now for the y-intercept, I go back to my origin, count down to where it crosses the y-axis. 1, 2, 3. Because I counted down, that means that the b value is equal to -3. All right, if we put this all together, we're going to get y equals -2/5 x minus 3. Let's fill that in on the next page. Y equals negative 2/5 x minus 3. All right, one more line. We'll do this one just a little bit quicker. The green line, my first point is at 1, 1, so over 1, up 1. My second point is at 2, negative 2, over 2, down 2, right there. And now let's connect that up with a straight line. Then a green line, do our best to go through those 2 points. Is this line right here parallel to any of these lines? It looks like it's parallel to line C right there. And since that's our last option, I think we can be pretty confident about that. Now we've already used 1 arrow and 2 arrows, so to show that these are parallel, I'm going to use 3 arrows on both of them. Make it match. So arrow, 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 showing that these ones are also parallel. Let's find an equation for this. Connect 2 points with a slope triangle. I use the 2 points they gave us. Going over 1 and then down 3. So my rise over run is negative 3 over 1. The y-intercept is up here. At this point, go back to my origin and count up to it. 1, 2, 3, 4. It's got the same y-intercept as the other one. For a final equation of y equals negative 3x plus 4. I simplified my negative 3 over 1 to be just a negative 3. So y equals negative 3x plus 4. All right, now down here, you can fill these in, but I'm just going to kind of talk it through up by looking up here. We knew that the red line was parallel to line B. I want you to notice something about this. Look at the slope of the red line. Look at the slope of line B. Do you notice something? Hopefully you notice that they match. Let's look at the brown line now. Brown line was parallel to line A. Look at the slope of line A. Look at the slope of the brown line. Again, they match. In good indication that there's some sort of pattern here. Let's just check it with one more. Green line and C were parallel, and again, the slopes match. So now I think we're ready for the next page. What did you notice about the slopes in each pair of equations? They matched. What do you notice about the y-intercepts in each pair of equations? Let's go back and take a look. This one had a y-intercept of 4. This one has a y-intercept of negative 2. It doesn't seem to be a connection there. This one, negative 3 and 1. This one, 4 and negative 2. There's no connection. So in terms of our equation y equals mx plus b, we could say same m didn't b. Let's apply that down here. Are these two parallel? Well, they've got the same m value, different b values, so yes. These ones here, those m values, they're different, so no. All right, now I'll let you fill those in where you name those lines. Let's find a couple slopes just from lines. I'm going to use the 2 given dots to connect with a slope triangle. I'm going to walk left to right along the slope triangle. I go to the right, 1, 2, 3, 4. I went to the right, so that's a positive 4. I went up, 1, 2, 3, 4. I went up, so that's a positive 4. Change of y over change in x equals 4 over 4 equals 1. What about this flat line here? My slope triangle would also be flat, meaning that the rise is flat, so this would be 0 over 1 or 0. You could also just remember that all horizontal lines have 0 slope. What about finding the slope from an equation? We don't need to do any manipulations, it's just the value in front of x. Negative 1/2 is the slope. Down here, 5 over 2 is the slope. No change is needed. And find the slope of a line parallel to each line. Well, we just discovered that slopes of parallel lines are identical. So the slope of a line parallel to y equals 2/5 x minus 3 is 2/5. They've got to match. And here, negative 7/3. They have to match. And that's all you need to do for that page. All right, let's do some perpendicular lines next. Similar colors, similar lines, but these ones are going to be perpendicular. Let's refresh our memory of what perpendicular lines are. Perpendicular lines meet at a right angle. These lines are perpendicular because this angle right here measures 90 degrees. All right, red line goes through 0, 2 and 2, negative 1. 0, 2 and 2, negative 1. There's our 2 points. Let's connect them up with a red line. Is this perpendicular to any of these lines? Well, if I get out my protractor and I put the cross of this protractor right at the intersection of these two lines, and then turn it so that it lines up with one of the two lines, you can look at the angle measurement by seeing where the other line hits the outside of the protractor. We can see that this black line here, which is labeled B, is perpendicular to the red line. All right, so these are definitely perpendicular, so I can add in a little right angle marker there, which is just a little box. Let's find an equation for the red line. I'm going to connect 2 points with the slope triangle. I'll just pick 2 given points. This one goes down 3 over 2. Rise over run is y equals negative 3 over 2x. And then the y-intercept is up 1, 2 from the origins where it crosses, so plus 2. For that, fill that in. Y equals negative 3 over 2x plus 2. And that one was perpendicular to line B. So maybe I'll just draw an arrow right there. All right, next up is the brown line. Let me just get rid of this. Brown line is going to go through the points negative 3, 6 and negative 6, 5. Negative 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. And negative 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 5. Connect them up with a straight line. And we can see that this one crosses line C at a 90 degree. Again, I can verify that with my protractor. And I've got an option for a full, but yeah, this could be useful. Put that right at that intersection there. You can see if I turn it, all of the angles are 90 degrees. So that intersects at 90, 90 and 180, those are 90 apart. It's all 90. All right, let's find the equation of the brown line. It goes up 1 over 3. So my rise over run is going to be 1 over 3. My y-intercept is way up here, counting from the origin. It's up 1, 2, 3, 4, 5, 6, 7. B equals 7. So 1/3 x plus 7. Let's copy that onto the next page. Y equals 1/3 x plus 7. And we saw that that was perpendicular to line C. All right, last one, green line, 4, 0, 6, 5. 4, 0, 6, 1, 2, 3, 4, 5. Connect these up with a straight line. We can see it's going to create a right angle right there with line. So give it a little right angle marker. Go back and give this one a right angle marker too. Let's find the equation of the green line. Connect 2 points with the slope triangle. I'll pick the 2 that were given. It goes over 2 and up 1, 2, 3, 4, 5. So my rise over run becomes 5 over 2. And then my y-intercept. Well, I didn't draw this line quite long enough, so I got to keep it going. But if I kept it going, it would actually cross right here at b equals negative 10. Negative 10 because we're below the origin now. So I'm going to add a negative 10 onto that formula and write my equation. Y equals 5 over 2x minus 10, which is perpendicular to this line. Now here the similarity in the slopes is not as obvious, but let me circle them anyway. This one has a slope of 2 over 3. This one has a slope of negative 3 over 2. Similar, but kind of different. This one's negative 3. This one's positive 1/3. This one's negative 2/5. This one's positive 5 over 2. So this relationship here, I'm going to give you a word for it. They are opposite reciprocals. And what this means is that it's the same fraction flipped upside down and one is negative and the other is positive. And that's our definition of an opposite reciprocal. So let's just practice that real quick. What would the opposite reciprocal of 3/7 be? Well, it would be -7/3. One is positive, one is negative, and it's the same fraction flips upside down. The y-intercepts, again, no connection. General statement about perpendicular lines. M's are opposite reciprocals. B's are not connected. All right, so 3x and 3x are the slopes here. Well, 3 is the slope. Are they perpendicular? No, but we actually just learned that this relationship is called parallel. No, they're parallel. Are these perpendicular? Yes, 2/3 and -3/2. Those are opposite reciprocals. We're going to call that good for this one. You can finish up the rest of the blanks on your own. And have a good rest of your day.